Learning goal number 15, scientific notation. Learning goal number 15, scientific notation. And scientific notation is a compact way of writing very large or very small numbers. And it's best to remember that very big numbers are going to have positive exponents, and very small numbers are going to have negative exponents. All right, let's first look at going from scientific notation to standard form. We have 5.34 times 10 to the 7th power. So this right now is written in scientific notation. We want to write it in standard form. And to do that, what we need to understand is that the decimal is going to move. And the decimal is going to move however many times the exponent tells us to. For example, in this case, positive 7. And it's actually going to move 7 places in the positive direction. Also, think of it this way. Positive exponent means really big number. If it's a negative exponent, you're thinking really small number. So in this case, it's 10 to the 7th power. So that means this decimal place is going to move 7 places to the right in the positive direction and make a bigger number. So 5.34, we're going to move it 7 places. 1, 2, 3, 4, 5, 6, 7. That's where it goes. Now, you can see that I moved it past 3 and 4, and then I created these sort of like waves or holes. Every empty hole I'm going to fill in with a 0. So 5.34 times 10 to the positive 7th is going to be 5, 3, 4, 0, 0, 0, 0, 0. Or it's going to be 53,400,000. Okay, 5.34 times 10 to the 7th, I move it 7 decimal places in that direction. All right, let's do another one. 3.27 times 10 to the negative 5. All right, now you can see that it's a negative exponent. Negative exponent, think small number, like small, like decimal. So what I'm going to do here is I'm going to move this decimal place 5 times in the negative direction. So if you think of a number line, positive in that way, negative that way. I'm going to take 3.27 and I'm going to move it 5 places to the left. Once, twice, 3, 4, 5. I put my decimal place, and again, anytime there is a hole or an open wave there, I fill it in with a 0. I'll put a 0 out front, just in front of the decimal place, but 3.27 times 10 to the negative 5th is equal to 0.00000327. I took this decimal and moved it 5 places in the negative direction to get a very small number. Positive exponent, big number. Negative exponent, small number. All right, now we're going from standard form to scientific notation. When doing this, you always have to remember this one rule. Finish with a number between 1 and 10. I always want my ending number to be between 1 and 10. All right, so let's start with a really big number. Okay, we have 530,000. Right now, the decimal place is right here. What I want to do is I want to move it until I get a number between 0 and 10. So if I move it here, that's 53,000. Nope. That's 5,300. Nope. That's 530. Nope. That's 53. Nope. That's 5.3, which is between 1 and 10, which is what I'm looking for. Finish with a number between 1 and 10. Now it's going to be 5.3 times 10. And then what power am I going to write it to? I moved it 1, 2, 3, 4, 5 places. Now, it was a really big number, and big numbers have positive exponents. So it's 5.3 times 10 to the 5th power. Again, really big numbers have positive exponents. Let's take a look at another example. Here we have 0.0000932. We want to move this number and represent it so it's between 1 and 10. So I start with the decimal, and I'm going to move it to the right. Once, twice, 3 times, 4 times, and 5 times, and I end up with 9.32. which is between 1 and 10, which I want. I'm going to write 9.32 times 10 to the 1, 2, 3, 4, moved it 5 times. It was a really small number, and really small numbers get negative exponents. So it's 9.32 times 10 to the negative 5th. Here we moved it 5 times from a big number, positive 5. Here we moved it 5 times from a small number, negative 5. All right, now you got to try a few problems on your own.